Resistance split motor, you see. So you are going to have the diagram is shown here. You see here, I am going to have a switch. And as soon as the motor is going to start, the auxiliary winding will be, as soon as the motor is started, this switch will move upward, so the auxiliary winding is cut off. So this motor behaves like a single phase, single winding motor. Very simple. Okay. And in these motors, in these windings, whatever you have considered, the resistance value will be very, very high. That's why it is called as a resistance split motor. See here, high R by X ratio is used. R by X means resistance to reactance ratio should be very, very high. Or I can say resistance is very, very large compared to reactance. Why resistance is required, more resistance is required means during the starting of the motor, very little amount of current should flow into your motor. So resistance value should be high. So between these two windings, I can achieve about a 30-degree phase shift. So the efficiency is low and it is available in this size. Okay. So that is the parameters are given here. And the torque speed characteristic is given here, you see. So when you have both main and auxiliary winding, so till you are attaining the synchronous speed, the torque will slowly increase and after that it will decrease. But after the motor is running, when you don't have the auxiliary winding, the torque will somewhat slightly come down and again it will increase and decrease. So the second maximum value is going to be called as your synchronous speed. So initially still N0, you see both the windings will be present. So once the motor is running at maximum speed, this auxiliary winding is cut off. Because of the auxiliary winding is cut off, the torque will slightly reduce and then slowly increase again to attain the maximum speed NS. So at this point, the switch is going to open, which means that the auxiliary winding is cut off. This is the torque speed characteristic of your split phase motor, resistance split phase